Hello there, and welcome to the Sleepy Astronaut, where curiosity gets cozy and science takes the scenic route to slumber. But before we dive into these dancing particles, I'd love to know where in the world you are watching from and what's your favourite quiet moment of the day. Fitting, isn't it? A video about connection, and here we are connecting across distances through the very technology that quantum mechanics helped make possible. If you find this voyage soothing, intriguing, or just a lovely way to ease into the evening, I'd be ever so grateful if you gave the video a like and perhaps subscribed. It helps this little corner of calm reach others who might need a peaceful pause in their day. Now, I do hope this isn't so fascinating that it keeps you awake. But if it does, well, at least you'll have learned something remarkable about the invisible threads that weave through our universe. So settle in, slow your breathing, and let's begin, because somewhere in the delicate dance of particles lies a story that connects us all in ways we're only just beginning to understand. Imagine, if you will, two coins that have developed an unusual friendship. No matter how far apart you take them, when one lands heads, the other always lands tails. Instantly, without any signal passing between them, without any delay, without any apparent reason. This sounds like magic, doesn't it? Like something from a fairy tale where objects are blessed with mysterious powers. But this is precisely what happens in the quantum world with particles that have become entangled. They form connections so profound that measuring one immediately affects the other, regardless of the distance separating them. It's as if they share a secret language written in the fabric of reality itself. Quantum entanglement isn't just a curiosity for physicists in laboratories. It's a phenomenon that challenges our most basic assumptions about how the world works. It suggests that at the deepest level, reality is far more interconnected than we ever imagined. It's like discovering that the universe has been whispering secrets between distant stars all along, and we're only now learning to listen. To understand this gentle mystery, we need to step into the peculiar world of quantum mechanics, where particles don't behave like the solid, predictable objects we encounter in our daily lives. Instead, they exist in what physicists call superposition. Imagine a coin that isn't heads or tails, but somehow both at once, spinning in an eternal dance of possibility. This is the natural state of quantum particles. They exist in multiple states simultaneously until the moment we observe them. And then, like shy creatures surprised by a sudden light, they collapse into a single, definite state. But here's where the story becomes truly extraordinary. When two particles become entangled, they share this ghostly existence. Their fates become intertwined in ways that seem to transcend the normal rules of space and time. If one particle is measured and found to be spinning up, its entangled partner will instantly be found spinning down, no matter whether they're separated by millimeters or millions of miles. It's as if they're two parts of a single quantum entity stretched across the cosmos. The discovery of quantum entanglement reads like a detective story filled with brilliant minds puzzling over nature's most cryptic clues. It began in the early 20th century when physicists were trying to understand the strange behavior of atoms and light. Max Planck had introduced the idea that energy comes in discrete packets called quanta, and Einstein had shown that light behaves both as a wave and as particles. But the deeper they dug into quantum mechanics, the more peculiar things became. And in 1935, Albert Einstein, along with his colleagues Boris Podolsky and Nathan Rosen, published a paper that would become famous in the physics community. They presented what seemed to be a paradox in quantum mechanics. If quantum theory was correct, then measuring one particle could instantaneously affect another particle far away. But this violated Einstein's own theory of relativity, which stated that nothing could travel faster than light. But nature, as it turns out, is far more creative than even Einstein imagined. The phenomenon he found so troubling is not only real, but has become one of the most thoroughly tested and practically applied aspects of quantum physics. The universe, it seems, does play dice, but they're very special dice that remain mysteriously connected across vast distances, creating correlations that our classical intuition simply cannot grasp. The mathematics behind quantum entanglement is elegantly simple yet profound. When two particles become entangled, they can be described by a single quantum state, even when separated by great distances. This shared state is written as a mathematical equation that captures the essence of their connection. It's like a poem written in the language of physics, describing how two separate things can be parts of one greater whole. But don't worry about the equations for now. Let's focus on the wonder of what this means. Imagine you have two magical music boxes. When you open one and it plays a melody, the other instantly begins playing a complementary harmony, no matter how far apart they are. There's no signal passing between them, no delay, no mechanism that we can see, yet they remain perfectly synchronized. This is the essence of quantum entanglement, a connection that exists beyond our everyday understanding of cause and effect. One of the most beautiful aspects of quantum entanglement is how it reveals the universe's hidden interconnectedness. We often think of objects as separate, independent things, but quantum mechanics suggests that this separation is, in some sense, an illusion. At the quantum level, the boundaries between things become blurred, and what we perceive as separate particles are sometimes aspects of a single quantum system. This interconnectedness isn't just philosophical, it has practical implications. Quantum entanglement is the foundation for emerging technologies like quantum computing and quantum cryptography. It's being used to create unbreakable codes and to build computers that could solve problems far beyond the reach of classical machines. The spooky action at a distance that Einstein found so troubling is now being harnessed to create technologies that would seem like magic to previous generations. Scientists have demonstrated quantum entanglement across increasingly impressive distances. They've entangled particles separated by hundreds of miles, using satellites to beam entangled photons between continents. They've even created networks of entangled particles, laying the groundwork for a quantum internet that could revolutionize how we communicate and process information. But perhaps the most profound aspect of quantum entanglement is what it tells us about the nature of reality itself. It suggests that at the deepest level, the universe is not made of separate, isolated objects, but of relationships and connections. The particles that make up your body were once part of ancient stars, and they carry within them the memory of those cosmic connections. In a very real sense, quantum entanglement reveals that we are all connected to each other and to the cosmos in ways that transcend our ordinary experience. The phenomenon also challenges our understanding of time and causality. When entangled particles influence each other instantaneously, it's as if they exist in a realm where the usual rules of cause and effect don't apply. Some physicists have suggested that quantum entanglement might be related to the very nature of time itself, that the flow of time might emerge from the quantum connections between particles. There's something deeply poetic about quantum entanglement. It's a reminder that the universe is far stranger and more beautiful than we often imagine. In our daily lives, we feel separate and isolated, but quantum mechanics whispers that this separation is not as complete as it seems. At the quantum level, we are all part of an intricate web of connections that spans the cosmos. The study of quantum entanglement has also led to profound philosophical questions about the nature of reality and observation. Some interpretations of quantum mechanics suggest that the act of observation itself plays a fundamental role in determining reality. It's as if the universe is constantly creating itself through the interactions between conscious observers and quantum systems. This doesn't mean that consciousness creates reality in some mystical sense, but rather that the universe might be more participatory than we once thought. We're not just passive observers watching a predetermined cosmic movie unfold. We're active participants in the ongoing creation of reality through our interactions with the quantum world. The beauty of quantum entanglement lies not just in its practical applications, but in its invitation to wonder. It reminds us that the universe is full of mysteries that challenge our assumptions and expand our understanding. It's a phenomenon that bridges the gap between the scientific and the poetic, revealing connections that exist beyond the reach of our senses, but not beyond the reach of our imagination. As we continue to explore quantum entanglement, we're discovering that it's not just a curiosity of the microscopic world. It might be fundamental to how the universe works at every scale, from the smallest particles to the largest cosmic structures. The connections revealed by quantum entanglement might be the threads from which the fabric of reality is woven. In laboratories around the world, scientists are pushing the boundaries of what's possible with quantum entanglement. They're creating ever more complex entangled systems, exploring how these quantum connections might be used to solve problems in medicine, communication, and computation. Each new discovery opens up possibilities that seem like science fiction just a few decades ago. But even as we learn to harness quantum entanglement for practical purposes, its deeper mystery remains intact. We can use it, build technologies based on it, and test its predictions with extraordinary precision. But the question of why the universe works this way, why particles can be connected across vast distances, remains one of the most profound puzzles in physics. Perhaps that's as it should be. Some mysteries are meant to inspire us to keep exploring, to keep questioning, to keep marveling at the extraordinary universe we find ourselves in. Quantum entanglement is one of those mysteries that reminds us that reality is far richer and more interconnected than we ever dared imagine. The particles dancing their entangled dance across the cosmos are telling us something important about the nature of existence itself. They're whispering that separation is an illusion, that connection is fundamental, and that the universe is woven together by invisible threads of quantum correlation. As we drift towards sleep tonight, carried by these gentle thoughts of cosmic connection, we might imagine ourselves as part of this grand quantum tapestry, connected to every star, every planet, every particle, in ways we're only beginning to understand. The same quantum fields that govern the behavior of entangled particles flow through us, connecting us to the universe in ways both subtle and profound. So rest easy, knowing that you are part of something magnificent and mysterious. A universe where particles can dance together across impossible distances, where connection transcends separation, and where the very act of observation participates in the ongoing creation of reality. The intricate dance between particles becomes even more fascinating when we consider what happens during the moment of measurement itself. You see, quantum entanglement doesn't just challenge our understanding of space and distance, it also reveals something quite profound about the nature of reality and observation. The very act of looking, of measuring, of trying to pin down the properties of one particle in an entangled pair sends ripples through the quantum fabric that touches its distant partner instantaneously. This is where the mystery deepens into something almost dreamlike. When we measure the spin of one particle and find it spinning upward, we don't just learn about that particle. We simultaneously determine the fate of its entangled companion, which will now be found spinning downward no matter how far away it might be. It's as if the universe maintains a perfect balance, a cosmic bookkeeping system that ensures the fundamental laws remain intact, even when individual particles seem to be communicating across impossible distances. The beauty of this phenomenon lies not just in its strangeness, but in its reliability. The particles don't seem to send signals to each other, at least not in any way we can detect or understand. Instead, they appear to share a single, unified existence that transcends our everyday notions of separate objects occupying distinct locations. Consider for a moment how this challenges our most basic assumptions about the world. We're accustomed to thinking of objects as independent entities, each with its own properties and behaviours. A chair is a chair, a tree is a tree, and they exist separately from one another. But quantum entanglement suggests that, at the most fundamental level, the universe might be far more interconnected than we ever imagined. Particles that have once interacted can remain connected in ways that seem to mock our understanding of space and time. The implications ripple outward like stones thrown into still water. If particles can be entangled, sharing properties and responding to each other's changes instantaneously, what does this mean for our understanding of causality? How can we maintain our belief in cause and effect when effects seem to happen before causes have had time to travel between distant locations? These questions don't have easy answers, but they point toward a universe that operates on principles far more subtle and interconnected than classical physics ever suggested. Scientists have discovered that entanglement isn't just a laboratory curiosity. It appears to be woven into the very fabric of reality itself. When we look at the quantum vacuum, that supposedly empty space between particles, we find it teeming with entangled pairs popping in and out of existence. The universe, it seems, is constantly creating these mysterious connections, these invisible threads that link distant regions of space and time. The process of creating entangled particles has become something of an art form in modern physics laboratories. Researchers have developed elegant methods for generating these quantum connections, often using crystals that can split single photons into pairs of entangled particles. These twin particles then carry away their shared quantum properties, maintaining their mysterious connection even as they travel in opposite directions. But perhaps the most remarkable aspect of entanglement is how it preserves information. When we measure one particle and collapse its wave function, determining its specific properties, the information about its entangled partner's properties is also instantly determined. This happens not through any signal or message passing between the particles, but through the fundamental structure of their shared quantum state. It's as if the universe has a built-in communication system that operates outside the normal constraints of space and time. The philosophical implications of this discovery continue to reverberate through our understanding of reality. If particles can share a single quantum state across vast distances, what does this tell us about the nature of identity and separateness? Are we truly separate beings, or are we part of a larger, interconnected web of existence that quantum mechanics is only beginning to reveal? These questions take us beyond the realm of pure physics into territory that touches on consciousness, identity, and the very nature of existence itself. Modern experiments have pushed the boundaries of entanglement even further. Scientists have successfully entangled not just pairs of particles, but entire groups, creating what they call multipartite entanglement. They've entangled particles separated by hundreds of kilometers, using satellites and ground-based stations to maintain these quantum connections across unprecedented distances. Each new experiment reveals that the universe's capacity for quantum interconnection seems to have no obvious limits. The delicate nature of these quantum connections adds another layer to their mystery. Entanglement is fragile, easily disrupted by interaction with the environment. The slightest interference can cause what scientists call decoherence, breaking the quantum connection and returning the particles to their separate classical existence. This fragility suggests that entanglement exists in a realm that's somehow separate from our everyday world, a quantum domain where different rules apply. Yet despite this fragility, or perhaps because of it, entanglement reveals something profound about the nature of reality. It suggests that the universe maintains a kind of quantum coherence, an underlying unity that persists even when individual particles are separated by vast distances. This coherence isn't visible to our everyday senses, but it's there nonetheless, connecting particles in ways that transcend our normal understanding of space and time. The mathematics of entanglement is equally beautiful and mysterious. The quantum state of an entangled pair cannot be described by listing the properties of each particle separately. Instead, it requires a mathematical description that treats the pair as a single, unified system. This mathematical unity reflects the physical reality that entangled particles genuinely share a single existence, even when they're separated by enormous distances. As we continue to explore the implications of quantum entanglement, we're forced to confront fundamental questions about the nature of reality itself. Are the particles really separate, or are they part of a larger whole that we're only beginning to understand? Is the universe fundamentally interconnected in ways that classical physics never suspected? These questions don't have simple answers, but they point toward a vision of reality that's far more mysterious and interconnected than we ever imagined. The study of entanglement has also revealed something profound about the role of observation in quantum mechanics. The act of measurement doesn't just reveal pre-existing properties of particles, it actually plays a role in determining those properties. When we measure an entangled particle, we're not just passive observers recording what we find. We're active participants in the quantum dance, helping to determine the outcome through the very act of observation. This participatory nature of quantum mechanics suggests that the universe might be far more interactive than we previously believed. Rather than being a collection of separate objects that we observe from the outside, reality might be more like a conversation between observers and the observed, a collaborative creation in which consciousness and matter dance together to create the world we experience. The mystery of entanglement continues to deepen as scientists push the boundaries of what's possible. They've discovered that entanglement can be swapped between particles, transferred from one pair to another in a kind of quantum relay. They've found that entangled particles can be used to teleport quantum information, sending the complete quantum state of one particle to another location without the information traveling through the intervening space. Each new discovery reveals another layer of the quantum world's strange beauty. Entanglement appears to be not just a curious phenomenon, but a fundamental feature of reality, a thread woven so deeply into the fabric of existence that removing it would cause the entire structure to unravel. It's as if the universe has a secret language, a way of maintaining connections and sharing information that operates according to rules we're only beginning to understand. The poetic nature of entanglement extends beyond its scientific implications. There's something deeply moving about the idea that particles, once connected, maintain their bond across any distance. It speaks to a fundamental connectedness in the universe, a suggestion that separation might be more of an illusion than a reality. In a world that often feels fragmented and isolated, entanglement offers a glimpse of a deeper unity that underlies all existence. As we stand at the threshold of a new era in quantum technology, powered by our growing understanding of entanglement, we're reminded that the universe still holds countless mysteries. Each answer we find seems to generate new questions. Each discovery opens doors to rooms we didn't even know existed. Now that we've explored the strange world of quantum mechanics and its peculiar relationship with time, let's step back and consider something even more fundamental. We've journeyed through equations that describe probability clouds and particles that exist in multiple states simultaneously. We've encountered the Wheeler-DeWitt equation, where time simply vanishes from the mathematics entirely. But there's something quietly beautiful happening beneath all this complexity, something that might help us understand why entanglement feels so mysteriously meaningful. You see, when we talk about entangled particles, we're not just describing a laboratory curiosity or a mathematical abstraction, we're touching on something that seems to whisper about the very nature of connection itself. Think about it for a moment. In a universe where everything appears separate, where objects have clear boundaries and distinct identities, entanglement suggests that separation might be the illusion, not connection. Consider how this plays out in the quantum realm. When two particles become entangled, they don't just share information. They become, in a very real sense, aspects of a single quantum system. The boundary between them dissolves. Measuring one doesn't send a signal to the other because there isn't really an other anymore. There's just one distributed reality expressing itself in two locations. This has profound implications for how we think about space and locality. In our everyday experience, things that are far apart are genuinely separate. The coffee cup on your desk has nothing to do with the moon hanging in the sky. But entanglement suggests that at the deepest level, this separation is more like a convenient fiction. The universe might be far more interconnected than our senses suggest. Some physicists have proposed that entanglement might be the key to understanding the emergence of space itself. Rather than space being a container in which things exist, perhaps space emerges from the pattern of entangled relationships between quantum systems. In this view, distance isn't fundamental. Connection is. Space is simply what happens when entangled systems become less entangled, when the web of quantum relationships becomes looser and more sparse. This idea leads us to something called the holographic principle, which suggests that all the information contained in a volume of space can be represented on its boundary. It's like how a hologram stores a three-dimensional image on a two-dimensional surface. The interior of the hologram isn't really there in the way we might expect. It's encoded in the relationships and patterns on the surface. If this principle applies to our universe, then perhaps everything we experience as solid, separate reality is actually encoded in quantum relationships at the boundary of space itself. The chair you're sitting on, the ground beneath your feet, even your own body might be holographic projections emerging from deeper patterns of entanglement. This isn't just philosophical speculation. Scientists have found tantalizing connections between entanglement and the structure of space-time itself. When quantum systems become more entangled, they seem to create more space-time. When entanglement decreases, space-time contracts. It's as if the fabric of reality is woven from threads of quantum connection. There's something poetic about this, isn't there? We often feel isolated, separated from each other and from the cosmos around us. But entanglement suggests that this isolation might be an illusion created by our limited perspective. At the quantum level, everything is connected in ways that transcend our ordinary understanding of space and time. This connects to something even more intriguing. Some researchers have begun exploring whether consciousness itself might be related to quantum entanglement. Now, this is highly speculative territory, and we should tread carefully. The brain is a warm, noisy environment that seems hostile to the delicate quantum states required for entanglement. But there are hints that certain biological processes might maintain quantum coherence longer than we once thought possible. Consider photosynthesis, the process by which plants convert sunlight into energy. Recent research suggests that planets might use quantum entanglement to achieve their remarkable efficiency. Energy absorbed by a leaf doesn't just bounce around randomly until it finds the right destination. Instead, it seems to explore multiple pathways simultaneously, using quantum superposition to find the optimal route. It's as if the plant is consulting a quantum map of possibilities before choosing the best path forward. If evolution has found ways to harness quantum mechanics in biological systems, perhaps consciousness represents another such quantum phenomenon. Maybe the unity of conscious experience, the way disparate sensory inputs and memories combine into a single, coherent awareness, reflects some deeper quantum integration. This brings us to one of the most beautiful aspects of entanglement, its apparent violation of what we call locality. In classical physics, things can only influence each other by direct contact or through fields that propagate at finite speeds. But entangled particles seem to share information instantaneously, regardless of the distance between them. This non-locality suggests that at the quantum level, the universe is not made up of separate parts interacting with each other, but rather of interconnected wholes that express themselves through seemingly separate parts. Einstein famously called this spooky action at a distance because it seemed to violate his principle that nothing can travel faster than light. But perhaps the spookiness comes from thinking about it backwards. Rather than seeing entanglement as separate things mysteriously communicating, we might see it as one thing expressing itself in multiple locations. The mystery isn't how the particles communicate. The mystery is how we ever came to think they were separate in the first place. This perspective transforms our understanding of what it means to be connected. In our daily lives, we think of connection as something that happens between separate things. I connect with you through conversation, through shared experiences, through empathy and understanding. But entanglement suggests a deeper kind of connection, one that doesn't bridge separation but reveals that separation was never quite real to begin with. This has implications that stretch far beyond physics. If the universe is fundamentally interconnected at the quantum level, then perhaps our sense of isolation and separation is a kind of cognitive illusion. We are not separate beings struggling to connect with each other and with the cosmos. We are expressions of a deeper unity that manifests through apparent multiplicity. The implications ripple outward into questions about identity, consciousness, and meaning. If you and I are both expressions of the same underlying quantum reality, then what does it mean to be an individual? If the boundary between self and other is as fluid as the boundary between entangled particles, then perhaps compassion and empathy are not just moral choices, but reflections of a deeper truth about the nature of existence. Some traditions of philosophy and spirituality have long suggested that separation is an illusion, that at the deepest level, all things are one. Quantum entanglement provides a scientific framework for understanding how this might actually be true. We are not separate observers looking at a disconnected world. We are participants in a vast, interconnected web of relationships that extends from the quantum level to the cosmic scale. This doesn't mean that individual identity is meaningless or that differences don't matter. Rather, it suggests that individuality and unity are not opposites, but complementary aspects of a deeper reality. Just as a symphony is both a unified whole and a collection of individual notes, perhaps consciousness and reality itself emerge from the interplay between unity and multiplicity, connection and distinction. The study of entanglement continues to reveal new mysteries. Scientists are discovering that quantum correlations can persist not just across space, but across time, creating connections between events that are separated temporally as well as spatially. They're finding that entanglement plays a role in everything from the efficiency of photosynthesis to the structure of black holes. Each discovery deepens our sense that we live in a universe far stranger and more wonderful than our everyday experience suggests. We are not isolated islands of consciousness in a sea of dead matter. We are expressions of a living, interconnected reality that manifests itself through countless forms and experiences. As we drift toward the end of our exploration, perhaps we can rest in this understanding. The quantum world reveals that beneath the apparent chaos and separation of ordinary experience lies a deeper order, a fundamental connectedness that binds all things together. Whether we call it entanglement, unity, or simply the mystery of existence, it reminds us that we are part of something infinitely larger and more beautiful than we can fully comprehend. In the quiet moments before sleep, when the busy chatter of daily life begins to fade, perhaps we can sense this deeper connection. Perhaps we can feel ourselves not as separate entities struggling through an indifferent universe, but as expressions of the universe itself coming to know itself through our eyes, our thoughts, our dreams, and our wonder. The mystery of entangled particles points to the mystery of existence itself. We are the universe becoming conscious of itself, quantum connections expressing themselves through human hearts and minds. Now let's explore how this mysterious entanglement ripples beyond the laboratory, weaving itself into the very fabric of technologies that are quietly reshaping our world. Because while we've been contemplating the philosophical implications of interconnected particles, scientists and engineers have been busy translating these quantum whispers into practical applications that feel almost like magic. Quantum computing stands as perhaps the most ambitious attempt to harness entanglement's strange power. Traditional computers process information in bits, each one either a 0 or a 1, like switches that are definitively on or off. But quantum computers work with quantum bits, or qubits, which thanks to the peculiar rules of quantum mechanics can exist in multiple states simultaneously. It's as if you had a coin that could be both heads and tails at the same time, spinning in a superposition of possibilities. But here's where entanglement becomes truly extraordinary in this context. When qubits become entangled, they form a network of quantum correlations that allows the computer to explore multiple solutions to a problem simultaneously. Imagine trying to find your way through a vast maze. A classical computer would methodically try each path one after another until it found the exit. A quantum computer with entangled qubits could, in a sense, explore all possible paths at once, collapsing into the solution with an elegance that borders on the mystical. The implications are staggering. Problems that would take classical computers millennia to solve might be cracked in hours or days. Drug discovery could accelerate dramatically as quantum computers model the complex interactions between molecules. Climate modeling could become precise enough to help us understand and perhaps mitigate the intricate dance of atmospheric systems. Financial markets, with their labyrinthine networks of interdependencies, could be analysed with unprecedented clarity. Yet quantum computers remain delicate creatures, sensitive to the slightest disturbance. Entangled qubits are like shy forest animals that scatter at the first sign of noise. Temperature fluctuations, electromagnetic interference, even cosmic rays can disrupt their quantum states. This is why quantum computers are often housed in chambers colder than deep space, isolated from the chaotic thermal motion that characterizes our everyday world. The engineering challenges are immense, but progress is accelerating. Companies like IBM, Google, and a constellation of startups are building quantum computers with increasing numbers of stable qubits. Google claimed to achieve quantum supremacy in 2019, demonstrating that their quantum processor could perform a specific calculation exponentially faster than the world's most powerful classical supercomputers. Though the calculation itself was somewhat artificial, chosen specifically to favor quantum processing, it marked a symbolic threshold, a moment when the quantum realm announced its arrival in the practical world. Beyond computing, Entanglement promises to revolutionize communication through quantum cryptography. Traditional encryption relies on mathematical problems that are difficult to solve, but not impossible. Given enough time and computational power, any classical encryption can theoretically be broken. Quantum cryptography, however, is secured by the laws of physics themselves. The principle is beautifully simple. When two particles are entangled, any attempt to measure or intercept one of them disturbs the quantum state, immediately alerting the other particle and, by extension, the legitimate recipients of the message. It's as if you were sending a letter sealed with wax that would show evidence of tampering, except the tampering is revealed not by broken wax, but by the fundamental structure of reality itself. Quantum key distribution networks are already operational in several countries, creating communication channels that are, in principle, absolutely secure. Banks, governments, and research institutions are beginning to adopt these quantum-secured networks, preparing for a future where classical encryption may be rendered obsolete by the very quantum computers that entanglement makes possible. The irony is delicious. The same quantum entanglement that enables quantum computers to break traditional encryption also provides the ultimate defense against such attacks. It's as if nature has provided both the sword and the shield, maintaining a delicate balance between the power to decode and the power to protect. But perhaps the most intriguing applications of entanglement lie in quantum sensing and metrology. Entangled particles can be used to measure physical quantities with unprecedented precision. Quantum sensors can detect gravitational waves, map underground resources, and even peer inside the human body with sensitivity that approaches fundamental physical limits. Consider quantum-enhanced MRI machines that could image the brain with molecular-level resolution, or quantum magnetometers that could detect the faint magnetic fields generated by neural activity. We might soon have quantum compasses that navigate without GPS, quantum clocks that keep time with such precision that they could detect the gravitational redshift caused by elevating them by a single centimetre. The technological landscape is shifting beneath our feet, and entanglement is one of the primary forces driving this transformation. Yet for all its practical applications, there's something profoundly moving about the fact that this most mysterious of quantum phenomena is being domesticated, channeled into circuits and protocols that serve human needs. It suggests that the universe's deepest mysteries aren't merely philosophical curiosities, but practical resources waiting to be understood and harnessed. The same entanglement that connects particles across cosmic distances might soon connect our devices, our communications, and our understanding of the world around us. We're living through a quantum revolution that's as much about engineering as it is about physics. The abstract mathematical formalism of quantum mechanics is crystallizing into tangible technologies that will shape the next century. And at the heart of this transformation lies entanglement, that strange quantum embrace that defies our classical intuitions while opening doors to possibilities we're only beginning to imagine. The particles that once seemed so alien, so removed from our everyday experience, are becoming our partners in building a future that would have seemed like pure fantasy just decades ago. In harnessing entanglement, we're not just developing new technologies. As we explore the deeper mysteries of entanglement, we begin to touch upon something that goes far beyond the realm of physics and into the very nature of existence itself. You see, quantum entanglement doesn't just challenge our understanding of particles and forces, it quietly whispers questions about consciousness, about reality, and about the profound interconnectedness that might weave through everything we know. Picture this for a moment. If two particles can remain mysteriously connected across vast distances, sharing information instantaneously in ways that seem to transcend the normal rules of space and time, what does this tell us about the nature of reality itself? What does it suggest about the boundaries we so carefully draw between self and other, between here and there, between now and then? Some of the most thoughtful minds in physics have wondered whether entanglement might offer us a glimpse into something far more fundamental than we initially imagined. Not just a curious property of subatomic particles, but perhaps a window into the very fabric from which reality emerges. A fabric that is inherently connected, inherently whole, inherently one. There's a beautiful paradox here that's worth dwelling on. Classical physics taught us to think of the universe as a collection of separate objects, each with its own properties, each occupying its own space, each following its own trajectory through time. It was a clockwork universe, precise and predictable, where everything could be understood by examining its parts. But quantum entanglement suggests something entirely different. It hints at a reality where separation might be the illusion and connection the deeper truth. Consider what this means for our everyday experience. We walk through the world feeling distinctly separate from everything around us. The chair you're sitting in, the air you're breathing, the walls around you, all seem to exist independently of your consciousness. Yet quantum mechanics whispers that at the most fundamental level, the boundaries between these things might be far more fluid than we imagine. The particles that make up your body were once part of ancient stars, and the entangled relationships they formed billions of years ago might still be influencing the quantum dance happening within you right now. This leads us to one of the most intriguing questions in all of science, the relationship between consciousness and quantum mechanics. Now, this is delicate territory where serious physics meets profound philosophy, and where speculation can easily outrun evidence. But it's territory worth exploring gently, thoughtfully, with the wonder of a child and the caution of a scientist. Some researchers have suggested that consciousness itself might emerge from quantum processes in the brain. Perhaps the mysterious unity of conscious experience, the way all your thoughts and sensations come together into a single, coherent stream of awareness, reflects some deeper quantum coherence in the neural networks of your mind. Perhaps the observer effect in quantum mechanics, where the act of measurement seems to influence reality, hints at a more fundamental role for consciousness in the universe than we've previously imagined. Others go further, suggesting that entanglement might help explain some of the most puzzling aspects of consciousness. How does your brain, made up of billions of separate neurons, create a unified sense of self? How do you experience the redness of red, the pain of loss, the joy of discovery? Could it be that consciousness itself is an emergent property of vast networks of quantum entangled states, creating a unity from multiplicity that mirrors the strange unity we find in entangled particles? These ideas remain speculative, dancing at the edges of what we can currently prove or disprove. But they point towards something beautiful and profound, the possibility that the mystery of consciousness and the mystery of entanglement might be intimately connected, that the very experience of being aware, of existing as a conscious being in the universe, might be rooted in the same quantum strangeness that allows particles to remain connected across the cosmos. There's something deeply comforting about this possibility. In a world that often feels fragmented and disconnected, where we can feel isolated and alone, quantum entanglement suggests that connection might be the most fundamental feature of reality. Not something we need to create or achieve, but something we already are, something we've always been, something we could never truly lose. Think about what this means for your relationships with others. If consciousness emerges from quantum processes, and if quantum entanglement creates genuine connections between particles, then perhaps your connections with other people, with other conscious beings, run deeper than you might imagine. Perhaps when you truly connect with someone, when you share a moment of understanding or love or joy, you're not just exchanging information or emotions, but participating in a dance of consciousness that reflects the entangled nature of reality itself. This perspective offers a new way of thinking about empathy, about compassion, about the strange ability we have to feel what others feel, to understand experiences we've never had, to care about beings we've never met. Perhaps these aren't just products of evolution or psychology, but reflections of a deeper truth about the nature of consciousness and its quantum foundations. Some indigenous wisdom traditions have long spoken of the fundamental interconnectedness of all things, of the web of relationships that connects every being to every other being. They've described reality as a living tapestry where each thread influences and is influenced by every other thread. Quantum entanglement, in its own precise scientific language, seems to be telling us something remarkably similar. That separation is an illusion, that connection is fundamental, that we are all part of a vast, interconnected whole. This doesn't mean that individual identity is meaningless or that personal boundaries don't matter. Rather, it suggests that individuality and connection might be complementary aspects of a deeper truth. Now, just as a wave is both a distinct feature of the ocean and inseparable from the ocean itself, perhaps consciousness is both uniquely individual and fundamentally connected to the larger field of awareness from which it emerges. The implications ripple outward in ways both practical and profound. If consciousness and entanglement are connected, then practices that cultivate awareness, that develop our capacity for presence and connection, might be doing more than just improving our mental health or emotional well-being. They might be aligning us more closely with the fundamental nature of reality itself. Meditation, mindfulness, contemplative practices that have been developed across cultures and centuries might be technologies for exploring and developing our quantum nature. When you sit quietly and observe your breath, when you open your awareness to the present moment, when you cultivate feelings of love and compassion, you might be participating in the same mysterious dance of connection that we observe in entangled particles. This is, of course, still largely speculative. The relationship between consciousness and quantum mechanics remains one of the great open questions of our time. But even as speculation, it offers us a way of thinking about ourselves and our place in the universe that is both scientifically grounded and deeply meaningful. It suggests that the mystery of who we are and the mystery of what reality is might be intimately connected, that exploring one might help us understand the other. And perhaps that's the most beautiful gift that quantum entanglement offers us. Not just a new understanding of particles and forces, but a new way of understanding ourselves. A recognition that the mystery of consciousness and the mystery of quantum mechanics might be two faces of the same deeper mystery, the mystery of existence itself. As we rest in this possibility, as we allow ourselves to feel the wonder of it, we begin to see that the strangeness of quantum entanglement isn't something foreign or abstract. It's something that might be intimately woven into the very fabric of our being, into the very nature of what it means to be conscious, to be aware, to be alive in this mysterious and beautiful universe. And in that recognition, the boundaries between science and spirituality, between objective and subjective, between self and cosmos, begin to soften into something more fluid, more connected, more whole. And so, dear wanderer through the quantum realm, we arrive at the close of our gentle exploration, though in the world of entanglement, perhaps endings are simply new beginnings wearing different masks. We've drifted together through the strange and beautiful landscape of quantum entanglement, where particles dance in invisible harmony across the vastness of space, where the very notion of separateness begins to dissolve like morning mist in sunlight. How wonderfully human it was of him to resist this mystery, to cling to the familiar clockwork universe where everything had its place and time moved in orderly fashion. And yet, as we've seen, the universe had other plans. Bell's theorem arrived like a gentle but firm correction, showing us that nature operates by rules far more subtle and interconnected than our everyday experience suggests. Through our journey, we've witnessed the birth of entanglement in laboratories around the world, watched as pairs of photons and electrons became cosmic dance partners, forever linked in their quantum waltz. We've seen how these invisible threads of connection challenge our most basic assumptions about reality, suggesting that at the deepest level, separation itself might be the grandest illusion of all. The mathematics, though elegant and precise, can only point toward the mystery, never fully capture it. Like trying to describe the taste of honey to someone who has never experienced sweetness, equations and formulas give us the structure but not the essence. The real magic lies in what entanglement whispers to us about the nature of existence itself. Consider for a moment the profound implications we've explored together. Two particles, birthed in the same quantum event, remain forever connected regardless of the distance between them. Measure one, and instantly, without any signal travelling between them, the other responds. It's as if the universe maintains a secret correspondence, a hidden network of relationships that transcends the ordinary boundaries of space and time. This isn't merely a curiosity for physicists to puzzle over in their laboratories. Entanglement is reshaping our understanding of information, computation, and communication. Quantum computers, those magnificent machines that exist in multiple states simultaneously, promise to solve problems that would take classical computers longer than the age of the universe. Quantum cryptography offers security based not on mathematical complexity, but on the fundamental laws of nature itself. Yet perhaps the most profound gift of entanglement lies not in its technological applications, but in its philosophical implications. It suggests that the universe is not a collection of separate objects bumping into each other like billiard balls, but rather a vast web of relationships, a cosmic conversation where every part is intimately connected to every other part. Some philosophers and physicists have wondered whether consciousness itself might be entangled with the quantum realm. Could our awareness, our very sense of being, be woven into the fabric of reality in ways we're only beginning to understand? While such questions remain at the frontier of speculation, they point toward a vision of existence where mind and matter, observer and observed, are not separate entities but aspects of a deeper, more fundamental unity. The ancient wisdom traditions spoke of this interconnectedness in their own languages. The Hindu concept of Indra's net, where each jewel reflects all others, mirrors the quantum understanding that every particle contains information about the whole. The Buddhist teaching of dependent origination, where nothing exists independently but only in relationship to everything else, finds an unexpected echo in the correlations of entangled particles. As we've seen, entanglement also challenges our linear understanding of time and causality. When two particles are entangled, the measurement of one seems to instantaneously affect the other, regardless of the distance between them. This doesn't violate the speed of light, but it does suggest that the universe operates according to principles that transcend our everyday experience of cause and effect. The implications ripple outward like waves in a cosmic pond. If reality is fundamentally relational, if everything is connected to everything else through invisible threads of quantum correlation, then perhaps our sense of isolation, Our feeling of being separate individuals in a vast and indifferent universe is itself a kind of optical illusion. This doesn't diminish the reality of our individual experiences or the importance of our personal journeys. Rather, it suggests that these experiences are part of a larger tapestry, threads in a cosmic weaving where each strand contributes to the beauty and complexity of the whole. Your thoughts, your dreams, your quiet moments of wonder are not isolated events, but part of the universe's ongoing conversation with itself. The mystery of entanglement also speaks to the paradoxical nature of knowledge itself. The more we learn about quantum mechanics, the more mysterious it becomes. Each answer opens new questions. Each solution reveals new puzzles. This isn't a failure of science, but perhaps its greatest triumph, the recognition that reality is far richer and more strange than our initial assumptions suggested. In our exploration, we've touched on the role of measurement and observation in quantum mechanics. The act of looking, of trying to pin down the properties of a quantum system, fundamentally changes what we're looking at. This suggests a universe where consciousness and physical reality are not separate realms, but intimately intertwined aspects of a single, unfolding process. The peaceful contemplation of these mysteries offers its own rewards. In a world often dominated by noise and urgency, the study of quantum entanglement invites us to slow down, to wonder, to embrace the beautiful strangeness of existence. It reminds us that beneath the surface of ordinary experience lies a realm of infinite subtlety and connection. As we drift toward the end of our journey together, perhaps it's worth reflecting on what entanglement teaches us about the nature of relationships themselves. Just as particles can become entangled and forever connected across vast distances, perhaps our own connections with others, with nature, with the cosmos itself, are deeper and more enduring than we typically imagine. The love we feel for others, the sense of beauty that stops us in our tracks, the moments of profound peace that occasionally grace our lives, might all be expressions of this deeper entanglement, this fundamental interconnectedness that quantum mechanics reveals at the heart of reality. So, as you continue on your own path, carrying with you the gentle wonder of quantum entanglement, remember that you are not a separate observer looking at a distant universe. You are part of the universe looking at itself, a conscious expression of the same cosmic process that creates entangled particles and spinning galaxies, quantum fields and sunset clouds. The mystery of entanglement, like all the deepest mysteries, is not a problem to be solved, but a reality to be lived. It invites us to expand our sense of what's possible, to embrace the beautiful uncertainty that lies at the heart of existence, and to find in that uncertainty not anxiety but freedom, not isolation but connection. In the end, the greatest entanglement might be the one between mystery and understanding, between the known and the unknown, between the seeker and the sought. We are all quantum wanderers, forever exploring the strange and beautiful landscape of reality, forever discovering new connections, new possibilities, new reasons to marvel at the extraordinary gift of existence itself. And so our gentle journey concludes, though like the particles we've contemplated, the connections we've formed through this exploration will persist. Invisible threads linking mind to mind, wonder to wonder across whatever distances the future may hold. The mystery of entanglement continues, and in its continuation we find not an ending but an invitation to keep exploring, keep wondering, keep marvelling at the magnificent strangeness of the universe we call home. Before we end our journey, can you comment where you're watching from? Also, let us know what time it is there. We love to hear people joining us from around the world to be a part of our community. Also, don't forget to leave a like and subscribe if you enjoy this story. Good night, fellow space explorer.